Download this code from codegive.com, link in the description below. OK, let's dive into fixing a compiler bug on Terry Davis Templeos live stream from 2016, specifically issue 593. This is a fascinating look into real-time debugging and the unique, and sometimes chaotic, development style of Templeos. Keep in mind that Templeos used its own custom compiler and operating system, so the concepts and code examples will be very specific to that environment. Background, Templeos and Terry Davis style. Before we get into the code, it's crucial to understand the context. Templeos a 64-bit, multitasking, Ring 0 operating system written entirely in holyc, Terry Davis' own variation of C. It's unique in that it was designed to be a personal, divinely inspired project. Terry Davis the creator of Templeos, known for his eccentric personality, genius-level coding abilities, and deeply held religious beliefs, all of which influenced the OS design and his approach to programming. Live streams. Terry Davis frequently live-streamed his development work, often improvising and making decisions on the fly. These streams provide a raw, unfiltered view into his thought process. The bug, issue 593, a compiler error. Issue 593, as you mentioned, refers to a specific bug that Terry encountered while live streaming. From the limited information I can gather from that time, since specific bug reports are not widely documented publicly, the bug likely centered around a compiler error during the compilation of some holyc code. The exact nature of the code causing the issue could have been one of the following scenarios. Inefficient expression evaluation. Incorrect usage of preprocessor. Stack overflow. Miscompilation. Dissecting a hypothetical Templeos compiler bug fix. Since the exact code from issue 593 isn't readily available, I'll create a hypothetical scenario that is representative of the types of issues Terry might have faced in his compiler. I'll show the kind of thinking process he would go through to identify and fix it during a live stream. Hypothetical scenario, preprocessor macro expansion issue. Let's say the Templeos compiler has a bug related to macro expansion within the preprocessor. Specifically, nested macros or macros with arguments that themselves contain macros are not being expanded correctly. The problem code, holyc. Expected behavior *. The calculate function should expand as follows. 1 sum, double, 5, 3. 2 sum, 2 5, 3. 3, 2 5, plus 3. 4 10 plus 3. 5 13. Therefore, the program should print 13. Actual behavior, with the hypothetical bug. The compiler, due to a bug in the preprocessor, might not be expanding the double, 5, macro inside the sum macro correctly. For example, it might leave it as a literal string double, 5, or only partially expand it. As a result, the code could produce a compiler error, crash, or print an unexpected result. Live stream debugging, Terry Davis style, hypothetical. Terry's initial observation God, the compiler's acting up again. Let's see what this damn thing is doing. He'd likely run the code and observe the incorrect output or compiler error. It's not expanding that macro right, it's got to be in the preprocessor. Terry's approach 1. Reduce the problem. Terry would try to isolate the issue by creating a minimal test case that demonstrates the bug. He might simplify the code to this. If this still fails, he'd simplify even further, focusing solely on the macro expansion issue. To insert debug prints *. Terry was a big fan of using print statements within the compiler's source code to trace its execution. He might modify the preprocessor to print out the state of the code at various stages of macro expansion. Let's assume the templeos compiler's preprocessor code is located in a file called preprocess.hc. Within preprocess.hc, he might insert print statements like this. This is highly simplified pseudocode of what the compiler's preprocessor might look like. These print statements would show him exactly what the preprocessor is doing at each stage, which macro it's trying to expand, and what the result of the expansion is. 3. Examine compiler source. holyc. Terry would then carefully examine the relevant parts of the compiler's source code, particularly the preprocessor. He'd look for logic errors in how macro expansion is handled, how arguments are substituted, and how nested macros are processed. For the fix *, let's say he identifies the bug. The perform macro expansion function, designed to handle the substitution of arguments in a macro, isn't recursively calling itself to expand nested macros within the arguments. It's only expanding the outermost macro. The fix would involve modifying the perform macro expansion function to recursively call expand macro on any arguments before substituting them into the macro body. Here's how the corrected code might look, again, highly simplified. A better fix might involve writing a more general-purpose routine to handle macro arguments. 5. Recompile and test *. After making the change, Terry would recompile the compiler itself. He'd then rerun the original problematic code and verify that it now produces the correct output. 13. 6. Live stream commentary *. Throughout this process, Terry would be talking to the stream, explaining his thought process, ranting about the compiler, this damn thing is possessed, and giving thanks to God for helping him find the bug. Key takeaways from a hypothetical Terry Davis debugging session *. Direct approach *. No fancy debuggers. Terry would often dive directly into the source code and use print statements to understand what was happening. Simplicity *. He favored simple, understandable code over complex solutions. Live debugging *. He was comfortable debugging live, sharing his thought process, and frustrations, with the audience. Faith *. His religious beliefs heavily influenced his work. Custom tooling *. He built his own tools and knew them intimately. Iterative refinement *. He'd often make small changes, recompile, and test frequently. Important considerations holyc. Remember that holyc has unique features and limitations that would influence the debugging process. Compiler complexity compiler bugs can be notoriously difficult to track down, requiring a deep understanding of compiler theory and the specific implementation. Terry's style Terry's debugging style was unique and may not be suitable for all programmers. Relevance today while templeos is not widely used, studying its development provides valuable insights into operating system design, compiler construction, and the mind of a brilliant, if unconventional, programmer. Disclaimer *. This is a hypothetical reconstruction based on my knowledge of templeos, Terry Davis, and general compiler debugging principles. The exact code and debugging steps from issue 593 are not readily available publicly. The code snippets are simplified for illustrative purposes and may not be directly runnable without adaptation to a templeos environment. By understanding the principles and thought processes involved, you can gain a better appreciation for the challenges of compiler development and the unique contributions of Terry Davis. Good luck on your coding journey.